Hello, welcome to the channel. In this video series, I'm going to review the Site Planning and Design Handbook. So let's begin with chapter 1, and that is sustainability and site design. So we know that humans have a significant impact on the world environment, and it's considered that 60% of the Earth land surface is under the management of people, but 100% of the world is affected by the practices of that management. The impacts of development and land use patterns were well documented during the last half of the 20th century. Impacts include a loss of water quality, fragmented and lost wildlife habitat, human health issues, introduction of invasive exotic plants, loss of biodiversity, fallen groundwater tables, and much more. So as development proceeds, isolated islands of green space and narrow visual buffers have some aesthetic appeal to the finished site, but they are commonly without significant ecological value. A variety of studies and reports detail the public and personal health impacts of some development patterns. Human health impacts range from obesity, hypertension, and respiratory problems to mental health concerns. The causes are equally diverse and include reduced air quality, traffic noise and vibration, sedentary lifestyles, and a loss of social capital. Public costs are higher as well. Numerous studies have found that suburban development, as it is typically done, does not raise sufficient tax revenue to pay for itself, and so drives the need for higher taxes for existing communities. Also, we know that the US currently has a population of more than 300 million people, and it's expected to grow to between 420 and 438 million people by the year of 2050, an increase of nearly 3 million people per year. It is expected that 20% of the US population in 2050 will be foreign-born legal residents, and that 82% of the increase in population will be due to immigrants, their children, and their grandchildren. To respond to this population increase, it's necessary to build the equivalent of a city the size of Chicago every year going forward. So let's take a look what that development may look like. About 80% of the buildings in the US have been built since 1960. Buildings are responsible for 48% of the increase in greenhouse gases produced by the US since 1990, an increase greater than emissions from either industry or transportation. A building constructed in Europe typically uses about 25% of the energy of a similar building in the US. The patterns of growth in the United States have changed as well. This pattern has been underwritten in part of by the road improvements that enable people to live further from the city centers and encourage more driving and more energy consumption. Much of the growth in the US is not a function of population growth. Several studies looked at the trends, and they found out that only 50% of the US development can be explained by population growth. So community leaders are frequently seen in local papers turning over a spade of earth to celebrate new business outside the existing urban center. The new facility, or often with new tax incentives, will draw employees to it and create traffic, require new infrastructure, and generate housing at the expense of the existing community. So generally, it takes 20 to 30 years for technology to move from the research and development phase to use in the land development and construction field. The reasons for this lag time vary, but include developing the awareness and demand necessary to bring along ordinances. However, a more common reason is the natural and predictable resistance of people to change. It is the job of the designers to find the synthesis of all these often adversarial views. The designer who has the greatest opportunity to innovate and introduce alternatives to the planning and design of sites and landscape, with a duty and responsibility for the health and safety of the public. The professional designer has the burden to make the site work. With the realization of the impacts of site development, introduce an alternative, more sustainable practices to site development can best be done by site design professionals. The change required by the introduction of new regulatory or permitting programs is a familiar experience for most of us. Contemporary site planning and design is changing to adopt into new practice much of the knowledge and information gained as our awareness of environmental risks has improved. Please refer to the little chart here in the textbook, and I highly recommend to back up my videos with the textbook because there are a lot of diagrams and images that will help you understand the concepts. So here you can see the chart, and it shows high risk problems, medium risk, and low risk problems. So for example, for example, the high risk problem is the global climate change, medium risk, airborne toxins, and low risk problems, thermal pollution, and so on. So site design has always been an issue of local control and practices because in part the conditions and needs of local communities and landscapes are too diverse to be addressed in any single ordinance or set of regulations. The increasing awareness of the need for more sustainable land development includes emergent practices that also have broad application and value. So when we take a look at the population and demographics, um, much of the population growth in the US is occurring in the Southwest and Southeast, and that is known as a Sun Belt. So the shifts in populations will put increasing pressure on existing supplies and require more conservation. Dryscaping and infiltration of stormwater are already becoming standard practices as part of conservation efforts. According to the US Census, 77 million people in the US were over 50 years old in the year of 2000. Retirees are not evenly distributed across the country, and you can take a look at the images here. For example, you can see that there is a map showing negative net migration and positive net migration. So the number of older people is expected to double in 2025. Also, it may be necessary to reconsider what our view of aging is, and key among our considerations is that the people who comprise this growing grain demographics are not easily captured by one set of characteristics. For example, reports often relate how healthy the aging population is, and in fact, the relative health of older people has continued to improve, but about 20% of them still report some form of disability or chronic illness. Please refer to another image that shows the percent of total population over 65. And we can see that, for example, Florida has over 25% of that age group. So the relative wealth of the retiring boomers has also received a good deal of interest. And much of this trend in retiree wealth is due to company-funded retirement, private savings, and Social Security, the often discussed three-legged stool. When we talk about the implications, we can say that with the anticipated increase in population, the need for water and energy conservation and plant growth becomes even more important, and smart growth becomes critical. The growing older population nationwide represents opportunities for design firms, but also represents significant challenges in some states where the majority of population growth is among the oldest people. The percentage of older people will continue to increase in the coming years, represented about 1 out of 5 people in the US by the year of 2050. Early indicators of two seemingly contradictory trends have been observed as retiring baby boomers move back into traditional large urban centers and into small towns. The reasons for these anticipated trends are equally diverse. Some retirees desire the cultural, civic, and social resources provided in large cities. Others seek to escape the city for the perceived benefits of small rural towns. Their decisions may in part lie in the costs associated with these choices. Small town life may be less expensive than an active urban lifestyle. In the end, these would appear to be quality of life choices by a very diverse demographic group. Both have important implications for communities and for site designers. Please refer to the chart here in the textbook, and you can see the population change from 2000 to 2025. And you can see the different data for all the states. So when we talk about anticipated effects of global climate change, uh, we need to know that these impacts are believed to be underway already and will begin to manifest significant changes on the environment within the next 25 years and beyond. Many of these changes and impacts have direct implications for the development of land. North America has a largely urban population. 75% of the population lives in cities or the suburban fringe of metropolitan areas. Moreover, 75% of the population lives in what are termed coastal communities, that is, communities influenced or situated by large bodies of water. The US is the world leader in production of greenhouse gases, the human cause of climate change. And as governments around the world have recognized the trends indicating climate change is already occurring, international pressure has been increasing for the US to change its behavior. The models used to predict climate change trends are projections based on complex sets of factors. Different models give different results, but in general, there is valid and significant agreement on global climate trends. There is a great deal of variability in the climate and weather of the United States and Canada, and projections of these models may have limited use on the local level, but it's important to know that observed changes in weather and climate, excuse me, are consistent with the predictions of global climate change. For example, the 2007 report from the Intergovernmental Panel on Climate Change, or IPCC, was significant for several reasons. First, it acknowledged that the evidence for human global climate change was unequivocal. This was the strongest language used in any of the 4 IPCC reports. Second, the fourth assessment report was the first to rely primarily on observed changes in global climate rather than model-based predictions. Even the best case scenarios of climate change indicate significant effects, but the effects are not expected to be the same everywhere. The world's oceans are warming up as well. The temperature of the sea is expected to rise and influence the weather. Thermal expansion of the ocean and increases in runoff water can damage the coastal communities. Also, ice melting from glaciers and ice fields are expected to continue and result in rising ocean levels. In places like Texas and Louisiana, rising seas may be made worse by concurrent land subsidence. The world's oceans are expected to rise by 20 inches or more by the year of 2100. Such an increase has significant implications for coastal communities. An increase in the intensity of hurricanes has been observed as the world's oceans have warmed. Perhaps a more troubling issue is the acidification of the world's oceans. In point of fact, the world's oceans are slightly alkaline, but there has been a reduction in the alkalinity of the seas as carbon dioxide levels in the atmosphere have increased. The seas absorb carbon dioxide from the atmosphere, and in doing so, help to mitigate the accumulation of the gas in the atmosphere. The sea level, as the sea level continues to rise, increases in shore and beach erosion should be anticipated along coastlines. Barrier island communities may experience significant losses. Local and state governments will be required to devise strategies for affected communities that may require significant public expense. Insurance for coastal properties can be expected to rise significantly. Reinsurance companies have reported catastrophic insurance losses associated with weather. And several major insurance companies announced that they would no longer write new flood insurance policies for properties within 2,500 feet of the mean high tide line in the states from Delaware to Mississippi, including waterfront along the bay. Beach replenishment will become an increasingly expensive and perhaps more futile effort. Barrier islands should be expected to shift landward in response to deepening oceans. Necessary mitigation methods, such as the construction or improvement of existing seawalls or bulkheads, or installation of revetments or levees on bayside beaches, would add cost to the beach replenishment efforts. It's important to note that some of these costs are already being paid. Sea level rise has significant implications for water supply as well. Saltwater encroachment may become a larger problem as coastline communities continue to grow and groundwater use increases. Coastal wetlands generally can adapt to nominal sea level rise and fall. As vegetation experiences seasonal diebacks, decaying detritus adds to the wetland soil and allows the wetland to lift in response to moderately rising seas. This capacity is believed to be limited to about a 2 millimeter per year lift. Sea level rise along much of the eastern coast of the US has exceeded this rate, and the rate of sea level rise appears to be increasing, in effect, drowning the wetlands. Rising sea levels will also complicate flood on tidal influenced rivers and streams. Increased storm surges may back up streams and change flood plain characteristics. Here, there is another chart showing estimated cost of sand replenishment for a 20-inch rise in sea level by the state. Precipitation patterns along the Gulf Coast, central and northern plains, and parts of the Midwestern and Northeastern US may increase as much as 10 to 20% annually. Please refer back to the textbook. There is another chart showing climate and sea level rise. And changes may not address all parts of a given state, so please be careful with the numbers. You may need some updated information. So more frequent and intense rains will result in increases in storm water runoff, erosion, and slope instability. The increase in runoff may require a rethinking of the maximum probable storm event in many places. It may require retrofitting existing stormwater collection and control devices to retain more water and encourage infiltration. Uh, let's talk about implications of climate change. It's possible that most of the US will experience an increase in the frequency of precipitation, both in terms of the amount of rainfall and its distribution. Increased erosion and perhaps slope destabilization in some places can be expected with such an increase. Coastal communities may experience an increase in flooding and beach erosion. Flood-prone areas may increase in size as the sea level rise. Public health officials and communities may become more sensitive to areas of standing water as subtropical and tropical diseases expand their range. Design strategies in affected coastal communities may provide significant opportunities for innovation and problem solving. When we talk about land use, we know that since World War II, the growth of suburban development has been the most important and possibly the most environmentally damaging trend. At the beginning of the 21st century, more people live in the suburbs than in the former urban centers. There has been a growing awareness that suburbs, as they have evolved, are unsustainable, but that awareness has done little to slow growth or change consumer preference. There is a general acknowledgement that cities offer a greater cultural experience, but population have not started to return in significant numbers. People have voted with their um, with their checkbooks and shown their preference for suburban living over city living. Builders respond to market demand. They do not, for the most part, create it. Changing such a trend would require changes to public policy that are politically difficult, if not impossible to achieve. Local ordinances tend to favor low density development and highways rather than parks and higher density development. It's difficult for planners and designers to influence this trend on a side by side basis, but planners and designers can address the impacts of suburban development through design. So please refer to the images here. The National Association of Home Builders study found that those surveyed would prefer to live within walking distance of schools, shops, and community facilities. The study also found that in spite of the standard practices of most zoning ordinances, people would rather live in a place with narrower streets and more public open space. During the time when American families have become smaller by nearly half, new houses have ballooned to more than twice their previous size. As the population has become older, however, there's an increase in interest in smaller homes. In some metropolitan areas, most of the homes built and purchased are townhouses and condominiums. Part of this popularity may be due to the cost of housing in urban areas, but many of these units are higher end dwellings located near shopping or social and cultural features of the city. The popularity of the southwestern US has its own significant challenges. The influx of people from more humid parts of the country has brought with it an expectation of life and aesthetic that often is simply out of place in the desert. The native people of these dry places have long ago found ways to live that recognize the character of their region. And let's take a look at the images here. You can see the contemporary urban neighborhood, and you can see other regions as well. So when we talk about energy, it's widely believed that the world is facing a time of increasing energy supply issues. The modern global economy and the US economy have grown in part on the foundation of relatively inexpensive energy, primarily provided by various forms of fossil fuels. We have leveraged the tremendous concentration of energy found in these fuels to create ever more productive processes and systems, which in turn enable the production of lower cost products, faster, cheaper transportation, and new materials. Let's talk about water. Much of the US enjoys an adequate supply of water, although the amount of precipitation and surface water availability declines as we move from east to west. Local variability is significant, ranging from 1 inch per year in the southwest to more than 60 inches per year in southeast. Such variability suggests the difficulty in finding wide-ranging solutions. Although water is a renewable resource, supply issues do exist and promise to become more significant as time passes. Annual natural variations in precipitation can result in local and regional water management issues and conflicts. It's unclear to what degree these natural variations will be exacerbated at the local level by climate change, but most climatologists agree that extreme weather events and patterns will become more frequent and more persistent, unfortunately. There are limited practical opportunities to develop or expand new sources of potable water. These include recycling water, desalination, expanding the use of existing sources, and conservation. Recycling water through gray water systems and other approaches have been successful in many places, but most often they are used in limited applications. The cost of recycling water on a community basis is at least several times more expensive than developing new public or community water. Desalination is energy intensive, and though technologies in recent decades have reduced the cost of desalinized water, it remains an expensive source of water. As energy costs continue to rise, the cost of desalinized water may also rise unless new advances can keep pace. Conservation is the most affordable and practical approach to the water issues factor in communities. Designers have an important role to play in water conservation. It's recommended that low impact design be utilized to reduce the water demand of a site and to maximize the amount of runoff retained on the site. Employing vegetated swales, constructing rain gardens, using permeable paving, and reducing lawn areas are important elements of water conservation in the site design. The use of gray water and recycled water for landscape purposes, selecting native plants, and collecting and storing runoff on site can also contribute to reducing the impact of site development. Working with architects to install green roofs and designing on-site sewage collection systems can also be part of the conservation strategy. Site design and planning have started to move beyond the practices and paradigm of the past. Designers working on the contemporary marketplace are or soon will be expected to bring solutions to the problems discussed that we discussed today. So that was it for chapter 1. Thank you so much for watching. I will see you in chapter 2.